continue on talking about managing nitrogen as a system, and I'll switch gears a little bit. I want to talk for a minute about variable rate nitrogen plans. Now, variable rate nitrogen plans have been around since 1998, or at least that's as long as I've been working on them. And there have been varying levels of success. Yield maps and differences in yields across the field landscape have driven this idea that a uniform rate of application of nitrogen, or any nutrient for that matter, makes very little sense. So in some of the highly variable fields, the range in yield between the lowest and highest yielding areas is much greater than the field average, of course. So figuring out the rate changes is the tricky part, and we're not constrained by technology. So what's really going to drive the decision is what information do we have available to change the rates. So 22 years ago, I set up a delta yield strips in this field. And I took nitrate soil samples at each one of the slope positions at side dress and time to determine the rates of nitrogen. And this delta yield concept is the difference in measuring yield response between using no nitrogen and using a rate of nitrogen. Otherwise, you're looking at true end responses. We examined the delta yield response on transects through the field by exporting the various passes out of the yield monitor and compensating for direction of travel. Topography has a strong influence on nitrogen supply, yield, and most importantly on the response to applied nitrogen. So very quickly look at this graph. We see the three lines, the red one being the yield going down the field with a zero nitrogen. Then the green line is the VRN that range between 40 to 140 pounds of N. And the dark blue line is a fixed rate of 120 pounds of N. You can see in the middle of the graph, the yields are all the same, whether we used zero nitrogen, 120, or variable rate nitrogen up to 140. And you see at each end of the field, there's these sandy knolls where we got this huge response to applied nitrogen. So 85 bushels at the front of the field, almost 120 bushels at the back. But there's good parts of the field in there where there's very little nitrogen response. So this is the key to understanding nitrogen response in a variable rate environment. So just quickly summarize the field by slope position. So if we look at the first 4 bars under the low slope, the first 110 pounds, that's the nitrate soil test first week of June. That's what we found in the soil. The 50 pounds was the recommended rate. 180 was the yield. The response to nitrogen was only 30 bushels. If we look at the mid-slope position where the nitrate soil test found 45 pounds of N, the recommendation was 136, the yield was 135, the delta yield or response to that nitrogen rate was 50 bushels over the 0 N. Then we go to that upper slope position, which would be the sandy knolls, and we see we only found 25 pounds of nitrogen. The recommendation called for 180 pounds of N, the yield was 90, and the response to nitrogen was over 60 bushels to the acre. So the risk here is if you just look at a yield map and just choose yield times a factor for nitrogen rate, you will tend to want to put more N on where the yields are higher and put less N on where the yields are lower. And as you see the response to nitrogen, the high yielding areas are likely the least responsive to nitrogen, and the lowest yielding areas is where you get your big nitrogen response. So that's one of the keys to understanding making variable rate nitrogen strategies, is understanding where the nitrogen response is occurring, not necessarily what the yield goals are. So even though this is 22-year-old data, I think it's still relevant because the slope positions are still there. The sandy slopes are still there. The mid-slope position, that low ground with a dark soil, high organic matter, lots of mineralizable nitrogen, lots of plant available moisture, high yield potential, those areas are all still there. So I imagine the absolute yields will change, but I doubt that the responses to nitrogen will change all that much. So it's my intention to get back to this field, repeat this trial from 22 years ago, and see what we can come up with and verify the positional responses to nitrate in the field. So basing variable rate nitrogen strictly on yield maps and just on yield is tricky business. So understanding the response to N would be one of the keys going forward in making a successful variable rate nitrogen maps. Thanks for listening. Stay safe, stay healthy. More to come.